to DF3 and DF4. So
but anyway, answers are the same, right?
no, sir. The questions are, you know, questions are not in the right
Options
order.
are shuffled.
Yeah,
Are
it's
not
not a right order. That I agree. Actually, questions are shuffled during the examination. Okay, but
exactly.
questions will be the same. I mean, the whole set of the paper is same for everyone.
No, sir. If it is a numerical answer, I know that what I have selected and what I have given in the answer is correct. So I know whether I have done it correctly or not. But in the case of a multi-select or a radio button, I would not know what is the option I have selected and what is the option that is correct. That is the problem.
Okay, okay. First of all, tell me, had you attended the yesterday's discussion session? Which one discussion session?
That I have attended, sir.
Okay, so those are the set of the questions which.
Yeah, I have no problem in the questions and the answers. I am pretty clear.
I got
Usually
your I
what?
got your
Yeah.
point. See, while in the TCS center, right? So everyone got the shuffled question actually.
I understand, sir. All these terms, whenever we did the exam, for us the question paper set and the answer key they used to match. So the question ID and the option selected, the numbers used to match, and we used to correctly select that particular answer key and check our answers. It was just whether that number is appearing or not. In this case, I know that I've done correctly. I know my answers are correct. But the thing is, there is no way that I can right now with the key that I have, I cannot calculate the answers correctly. That's what. Just mentioning it here, I have no issues.
Yeah, okay, I got your point. I got it. So we'll take care of it. Thanks. Okay, so meanwhile, we are live now. Okay, so how many of you seen some lectures video of week 5? You can raise your hand. I will be having some idea. Okay,
Sir, it's not fully done, but I'm in the middle of the videos.
Okay.
Last video is left, sir.
Yeah.
Okay,
Yes,
okay.
me also.
Fine, no problem.
In
So what
week
do you
5
want?
there is
Should
only
we
three lectures.
cover the concept wise?
Yes,
No,
sir.
sir.
Yes, sir.
We are not.
Concepts
Yes,
also.
sir. We will cover the concept wise.
Okay, will that be fine, right? Okay.
Sir,
Yes,
but
sir.
in this week, I did not get anything, sir. Like not clarification about the topic.
That's why we are saying we are going to discuss the concept.
Okay, sir.
Okay, yeah.
Okay, sir.
Yeah. Okay, so no worries. Okay, just give me a minute. I will start. Okay. Okay, so let me share my screen. Okay, so can you see my screen? Is it this white PDF is visible for you?
Yes, sir.
Okay, fine. So, okay, so in week 3 until week 4, I think till week 3 we have discussed about discrete and all, right? If the function of discrete random variable is given to you, then you can find the PMF and all. Okay. So in case of now we are moving to the continuous word. Okay, from week 4 itself, it's called PDF. Okay, like for discrete we are saying it's a probability mass function. Okay, and but for continuous we are saying it's a probability density function, right? What is the density? Anyone?
Mass upon volume.
Mass upon. Okay, so
Volume.
volume. Okay, so basically that is something we are interested to find out that region. Okay, suppose we are interested to find out the area, so we have to integrate this thing. Now in week 5, what are the main topics? So we are going to discuss the function of a continuous random variable. Okay, second topic we will be discussing expectation of a continuous random variable. And then I think last topic is, I think it's about I think it was last week lecture, joint distribution of discrete and continuous random variable. Joint distribution of discrete and continuous random variable. Okay, so let's try to understand the things. So first of all, we are going to discuss the function of continuous random variable. So how will you proceed for function? So very first approach is try to find the CDF of the function of continuous random variable first. Okay, means we have to find the CDF of this is the very first step. CDF of the function of continuous random variable. Okay, so this is something we have to find. For example, suppose I'm saying x is the continuous random. I'm writing CRV for a continuous random variable. Okay, so let's say it had the CDF, let's say capital F of x, and let's say PDF small f x. Okay, this is something we have information. So I'm saying there is a function g which is from R to R. Okay, this is the function. Okay, how it is defined? You can define. Basically it can be. It will be continuous function of your x. Let's say I'm saying there is a y. I'm denoting y as a g of x, which is the function of x. Okay, it's a random variable. It will be again a random variable with CDF. Okay, f of y. So what will be the f of y? Basically, we have to start f of y. So capital F of y means normally we are denoting capital F of y as. So I can write probability of y lesser equal to y. Yes, no?
Yes, sir.
Yes, sir.
Correct. And instead of y, we have to replace whatever function I have. I will write g of x lesser equal to y.
Yes.
Correct. So thing is that where here you have to find how will you proceed from here. Basically, we have to find the probability that x, okay, which will be like that x given your gx will be lesser equal to y by following this condition. So basically, what is this? This is nothing but probability of an event, right? Yes or no? If you say this is yes, this is nothing but probability of an event, right? Okay. Okay. Let's try to understand with an example. Okay. So basic thing is we have to start with the CDF of function of continuous random variable. Okay. Let's do one example. Suppose I'm saying x follows. Okay. Uniform -1, 2. Okay. This is a continuous uniform distribution. I have defined y as a g of x, which is 2 times of x. Okay. So question is find the CDF of y. Okay, so by the above approach, first of all, tell me what will be the CDF of your x? Yeah, tell me what is the CDF of your x?
Sir, 1 by b plus a, sir.
1 by b plus a, that is CDF or that is PDF?
PDF b minus a, x minus a upon b minus a.
X minus a. See, if I'm saying x follows uniform a comma b, right? Then CDF capital Fx is nothing but, okay, let me write down here. Suppose I'm saying x is follows continuous uniform distribution a comma b, then PDF is defined by 1 upon b minus
B
a
minus
for
A.
the region A to B, and it will take value 0 for otherwise. And how CDF is defined as CDF is nothing but probability x less or equal to x. This means, and this is nothing but basically x minus a divided by b minus a for the I mean this support, okay. And when x is less than a, it will be 0, right? And x is greater or equal to b, you can it will be 1. That is the something CDF we are defining, yes or no?
Yes.
Correct. So for this function, for this given uniform minus 1 comma 2, what will be my CDF? So it will be x minus a. So what is the x here? Basically x minus a. So minus 1 divided by 2 minus 1, right? Are you getting my point? What I'm trying to say here?
Yes, sir.
Yes,
Getting,
sir.
sir.
Yes, sir. Right.
Okay. So what it will be now? It will be x plus 1 divided by 3, right? I'm going to write down directly. Correct? So it will be x plus 1.
Greater than 1 is equal to, sir. Greater than 2, sir. 1, na, sir.
Sorry, yeah, it's 1. Yeah, thanks for the correction. It will be 1. Okay. So now, how will you start basically to find the CDF of y? First of all, how to start? So what is Fy of y? So it's nothing but probability y less or equal to y. Yes or no?
Yeah. Yes.
Correct. Now, so we know I told you. So instead of y, we have to replace the function, right? Gx less than y. Now it's a 2x less or equal to y, right? See this random. See this small y is one of the value you can say. So it's 2x less or equal to y. Yes or no?
Yes.
So from here
Yes,
I
sir.
can see x is less or equal to y by 2.
Yes, sir.
Yes, sir. We can.
So what is this? This is nothing but fx of y by 2.
Yes, sir.
Correct?
Yes, sir.
Correct. And what we got fx as? See, instead of small x, now I have fx of y by 2, right? Are you getting my point? So this I can replace small x with y by 2 or not?
Yes, sir.
Correct?
Yes, sir.
Because this is what
Yes,
is
sir.
it? This is the CDF of x now, correct?
Yes.
Yes. So it will be basically y by 2, okay, plus 1 divided by 3, right? Yes or no?
Yes, sir.
Okay.
Yes, sir. Yes.
Okay. So it will be now y plus 2 divided by 6.
Yes, sir.
What, okay, now tell me what will be the support of y now?
Support of y.
If x is minus 1 to 2, then what will be the range of y?
0.5 to minus 0.5 to.
I prefer 1, sir. Minus 0.5 to 1, sir.
Y is defined as 2x.
Oh,
Okay.
sir.
Minus 2
sir.
to 4. Okay.
Minus 2 to 4. Yes, sir.
Okay.
Yes, sir.
So this is the
2 to 4.
okay. So this is the CDF of your y. Okay. If this is the CDF of your y, okay. Now can I write this as y minus of minus 2 divided by 4 minus of minus 2 or not? By this range.
Yes, sir.
Okay.
Yes.
So
Yes, sir.
what I can say from here? Can I say y follows continuous uniform distribution with minus
Yes,
2
sir.
comma
2 to
4?
4.
Yes,
Yes,
sir.
sir. Minus.
Now I got the distribution of y.
Yes, sir.
Correct? It's clear?
Yes, sir.
Yeah. So this is the something. I mean, the very first thing we can start with our like CDF part actually. Okay. Okay. So I think one theorem is there. Okay, that is called, if you have seen, if you can recall, it's called monotonic differentiable function. I mean that differentiable function
Yes,
theorem.
sir.
Yes,
Okay.
sir.
Yes, sir.
Okay. How? Okay. Can you tell me what do you mean by monotonic?
It means only decreasing, only
Increasing or
increasing,
increasing.
not decreasing, not increasing. Like both functions are not included in a graph, sir. Like
Yeah. I mean monotonic function is. I mean that is a function which is something. It will increase or it will decrease, right? Okay.
Yes.
Basically, it's in monotonic way actually. Okay. Let me write down that theorem itself. Okay. Okay. So there is one theorem which is helpful, but with some condition. What is that condition? Okay, I will explain. So theorem called monotonic differentiable. Okay. Function theorem. Okay. Okay. So what does what this theorem says? Okay. So question paper is there on portal. You can find from the portal itself. Okay. So this theorem says, suppose okay, x is a continuous random variable. Okay, with PDF. Okay, it will be, since it's a continuous random variable, it will be having some PDF. Let's say fx of x. Okay. Now I'm saying let's gx be monotonic. I mean, it's a monotonic function. Okay. So we have to identify whether it's a monotonic function or not. It's a monotonic function for the support of x. Okay. Okay. And it's a differentiable also, means if it's differentiable, I can differentiate this function. Then I'm saying with derivative. Okay. So this gx is anything. So I'm saying with derivative g dash x will be somewhat d of gx divided by dx. This is something I can find the differentiation, right? Okay. Then
Yes, sir.
the PDF of y means that function of x will be given as fy of y. So this theorem we can directly apply 1 upon modulus of absolute value of g dash g inverse y, okay, into fx of g inverse y. Okay. So we'll try to understand the meaning of each terms here. Okay. So
So
basic thing
what
is,
is support of x, sir?
so support of x in normally and okay. So in discrete case, what we are saying, it's a range of x, right?
Yes, sir.
Okay. So in continuous, we are treating as a support of x. Okay.
Okay, sir.
Okay. Yeah. So okay, what is this function? Okay. So first of all, let's see. Suppose I'm saying I have one. Let me take one example. After that, okay. Suppose I'm saying we'll try to understand the meaning of each term here. Okay. Okay. Suppose I'm saying x follows exponential distribution with parameter lambda. Then suppose question is what is the PDF of y equal to x square. So this x square is nothing but gx, right? Yes or no?
Yes, sir.
Yes, sir.
So okay, let's try to understand the things. Now, first of all, we'll see whether the function is monotonic for the your x or it's a differentiable or not. Okay. So what is the PDF for this exponential distribution? It's a lambda into e raised power minus lambda x when x is greater than 0, right? It will take value 0 other for otherwise. So this is something PDF of your exponential distribution, right?
Yes.
Okay. What we have to see the x square. So if you will draw the x square, right? So this is the x, okay. This is the gx. So we have to draw the x square. So x square look like something like this. When for the support of x, if you see for the support of x when x is greater than 0, then this graph of x square for x greater than 0, this is the monotonic.
Yes, sir.
Yes,
Yes
sir.
or no? Are you getting? So we have to see the monotonic property in the support of x. Okay. Okay. This till this one is clear. You got the point. So now I can use the theorem directly. Okay. So what does theorem says? We have to find the g inverse of y. First of all, let's find g inverse y. G inverse of y. What does this mean? Okay. So I have y equal to x square, right? If I have y equal to x square, so can I write this as a, let's say x equal to square root of y?
Yes, sir. Solve for y x.
Yes, sir.
Yes or no? So if you
Yes.
see, what is this? if I'm writing y equal to gx, then can I write x as the g inverse y?
Yes, sir.
Okay. So if in the place of x, left hand side, I will write g inverse y is nothing but square root of y.
Yes, sir.
Yep.
Correct? So far, so good. Now we have the square root of, we got the g inverse y. Means I can simply replace the fx thing here. Now we have to differentiate the g dash g inverse y, means we have to differentiate this thing. So if you see, first of all, so I have gx as x square, right?
Yes,
This is
sir.
the function, correct? So g dash x will be 2 times of x, differentiation of x square.
Yes, sir.
Yes or no? Are you getting?
Yes.
So from here, if you
Yes,
see
sir.
g
Getting.
dash in the place of x, I have g inverse y. So I will simply write 2 times, and at the place of x, I can replace this x y. So I have this term.
Yes.
I got this term.
I have also doubt in this stage in a lecture
Hmm.
also,
Hmm.
like g prime of
Hmm.
g inverse y.
Hmm.
Like we get that g inverse of y is equal to under root of y.
Hmm.
We differentiate under root of y. We not get that, sir. Like under root of y,
Hmm.
we differentiate it with respect to y. We get uh, half of 1 by root y, sir.
No, no, no. What are you saying? You are saying you have to differentiate this one.
Yes, sir.
Why?
Yes, sir. Like in
Hmm?
the formula, sir, in formula,
Hmm.
g prime of g inverse of y, sir.
Okay, that is the same thing here. I'm doing, right.
Then, sir, we differentiate under root y. Then we solve. We should get the same answer, sir, like 2 under root y, sir.
No, no. If you differentiate this one, see. Okay, first of all, tell me this one is okay or not?
This is okay, sir. But direct from formula, I did not get how it is connected to this, sir.
Okay. See, first of all, tell me. Uh okay, let me tell you what we are doing here. Okay, suppose I'm saying with let me take you in general. If we are taking the translation part, okay. Okay, first of all, let me finish by this one. I will explain you why we'll do that one. Okay, I will take some transformation thing. Maybe you will get some idea. Okay.
Okay, sir.
Okay. Now, I think so. This is the y equal to x square. If I have x equal to square root of y, that's fine. So at the place of x, I can write g inverse of y. So gx is x square. G dash x is basically, you see, we are differentiating in terms of with respect to x, right? I think. See, if you see the theorem itself, right? Okay. I mean, gx is a function with this derivative thing. Okay. Then at the last, we can replace the value of y. Sorry,
I did
value of
not.
x. See, I'm saying I have the function of x. Okay. Any function of x. Let's say gx is, let's say I'm saying x square. Okay.
Okay.
Fine. So what I'm saying, this is the function with some derivative g dash x. Okay.
Mm.
And with something like this dgx of gx divided by dx, right?
Yes, sir.
So what will be g dash x here? It will be 2x, right?
Yes, sir.
Now we have to replace the value of x. I got your point. You are directly
Yes, sir.
differentiating your with this one, right? I
Yes,
mean,
sir.
okay. So I got your point, but we have to see if you see the theorem itself, right? We have to see that gx is the monotonic function with this derivative. Meanwhile, I will take that transformation. Maybe you will get some idea. Okay, don't worry. Okay, yeah. So if you see, I have this value. Yes, correct. And I got this value also. So what our theorem says, f of y. Okay, first of all, if what is the fx? fx of x was lambda e raised to power minus lambda times of x, right? Then fx of g inverse y will be what? Tell me.
Lambda 8 e to the power minus lambda g inverse of y.
Lambda into e raised to power minus lambda. Instead of x, I have to replace the value, right? So what is the value of x?
Yes.
Square root of y?
Root y.
Root of y. Okay. Now I can apply the theorem directly, right? So f y of y will be 1 upon modulus of g prime g inverse y, okay, into f x of g inverse y. Okay. So now you will be having, so 1 upon 2 root pi y, sorry, not pi, into lambda into e raised to power minus lambda root y. Okay. For what range support of y? Yeah, tell me what will the support of y here?
Minus 2 and 4, sir.
Minus
2 and 4.
y?
Sir, what is
Greater
the
than,
range?
sir, E, sir, greater than 0.
It's greater than 0 simply, right? Because if you see,
Yes.
what is your x?
Exponential.
What is your x? X is something greater than 0, right? Yes or no?
Yes, sir.
Okay. Yeah.
This was
Yeah.
greater
So
than 0.
let's okay. So this one is clear. Something you to first you to identify whether it's a monotonic or not for that support. Okay. If it's monotonic, then we have to. I mean, I can simply like find the. I mean, I can simply differentiate, and I can find the value of that. Yes or no? Yes. I mean, are you getting the point, or is there any difficulty? Right. Okay.
Getting.
So, getting, yeah. Okay. Let me take some another example. Let's say I'm saying X is following uniform with range, let's say 0 to 10. Okay. And I'm saying G of X, which is Y, it has been defined as, let's say, 27 times of X cube. Okay. For example. Okay. Now, if you see, what is the support of X here? So, what is the CDF, sorry, PDF for X? It will be 1 upon 10,
10. Yes, sir.
right? For this region, okay, and 0 otherwise. Now, tell me by this, seeing this function, whether it's a monotonic, I mean, it's a monotonic or not? Your GF.
Yes, sir. Monotonic,
Yes.
sir.
It's a monotonic, right? Because X cube, you will get something like that. I mean, it's a curve one, right?
Sir, one question. You told that first we need to calculate CDF, but here you calculated PDF.
Okay, so it's a PDF of X is given to us. See, that property we'll see. So actually, this is something. If monotonic is there, differentiable is there, I can use the directly theorem. If it's not, I will proceed with the CDF. I will take one lecture video. I think I saw one post in the discourse itself. I will take that doubt. Okay.
So here we have calculated PDF. Correct.
See, to get the PDF, to get the distribution part, okay, so we have to start with the CDF. If it's not given to you, I mean, it's not monotonic and all.
Okay.
Okay, get it? Okay, so basically X cube graph, we are getting something like this, right? I mean, it's like this, something like this. Yes or no? Okay. So it's in this support, I will get the upper part only 0 to 10. Suppose 10 is there. Yes or
Yes,
no?
sir.
Correct.
Yes.
So it's a monotonic for the given support. Okay. Now, what
Sir,
is the, yes?
how did you calculate 1 by 10 for the support 0 to 10?
What is this?
Uniform
What is the PDF of uniform
distribution.
distribution?
Got it right now, sir.
Tell me, what is the PDF of uniform distribution?
1 upon b minus a.
Can't recall. 1 upon b minus a.
Okay. So this is the A, this is the B.
Okay.
Okay.
Okay, sir.
Fine. Yeah.
Fine.
So this is the something. Now, what is the next? I have to find the differentiation of this function. So what is the g dash of x? It will be
27 into 3 x square.
basically 81 times x. There's some background noise. Love, can you mute?
Oh,
Yeah.
sorry, sir.
Yeah, no problem. Yeah. Whenever you are done, you can unmute. Not a problem. Okay, now. So from here, if you see, I have, okay, so see, this is similarly, I can write y equal to 27 times x cube. So what will be the value of x here? So y upon 27, right? Raised power 1 by 3. Yes or no? So this is
Yes, sir.
something I can write x equal to, this is the separate part, x equal to y raised power 1 by 3 divided by 3. Correct?
Yes, sir.
Yeah, do let me know if at any step you are not getting. Now, I have to find,
So can you please explain after the y is equal to 27 x cube?
okay, so this is something gx equal to 27 times x cube, right? So what is gx? Gx is nothing but I'm denoting with another random variable which is called y. Okay, so y equal to 27 times of x cube.
To get the inverse.
To get the inverse part basically. Okay, so x will be what? Y divided by 27 x cube first of all. So if you are not getting at the same point, okay, let me do a little bit. Okay, so from here I can write x cube equal to y by 27. Yes or no?
Yes, sir. It is a simply equation of
So
solving
yes,
for x.
so now from here onwards I can write y by 27 raised power cube. Sorry, 1 by 3.
1 by 3, sir.
So from here I can write 1 by 3 divided by 3 because this 27 you can write 3 raised power 3. Okay. So that 1 by 3 will cancel out. Yes or no? Fine. So this is your x. So this x I can write as nothing but, this is nothing but g inverse y, right?
Yes, sir.
Okay. Now, if you see, so from here onwards, so what is the g transpose g inverse of y? I mean, not transpose, this means derivative, g dash. So it will be 81 times, right? Instead of x, I have to replace g inverse. So 81 times g inverse y square, right? And what is the value of g inverse y basically? Or what is the value of x? This is y raised to power 1 by 3 divided by 3 whole square.
Y, sir. Yes.
Correct? Yes or no? Everyone is getting just
Yes, sir.
Yes, sir.
we are substituting the value. It will be 81 into y raised to power 2 by 3 divided by 9
9.
because 3
Yeah.
square. Okay. This 9 will get cancelled out. So I'll be having 9 times y raised to power 2 by 3. Correct? So
Yes.
I have this value. Now I can use this formula itself directly. What is tells us 1 upon absolute value of g dash g inverse y, okay, into fy of fx of g inverse y. Okay. Now, so this is the bracket one. So it will be 1 upon, okay, modulus of 9 into y raised to power 2 by 3, okay, into basically fx of, so what is fx of g inverse y? So fx of x is nothing but 1 upon 10. Okay. So fx of any, if you change this as a y raised y by y raised power 1 by 3 divided by 3, again it will be 1 by 10 itself, right? It's just a constant. Yes or no?
Yes, sir.
Yes.
Correct? Irrespective of the value of, so basically this is y raised power 1 by 3 divided by 3. Again I will get 1 upon 9 times modulus of y raised power 2 by 3 into 1 by 10. Now tell me what will be the value of this thing? I mean support of x, y. I can write this as y raised power 1 by 3 divided by 3 less or equal to 10 because x is between 0 to 10.
Yes, sir.
Okay. So if this is the case, okay. Now tell me what we'll get. So 1 upon, basically I will get 90 modulus of y raised power 2 by 3 into, I mean not into, 10 we have multiplied. So from here, tell me what will be the range support of x? It will be y 1 by 3, 30. Yes or no?
Yes, sir.
If you will take the power cube for all, then what you will get? Tell me. 0 to y to 27,000.
Yes, sir.
Yes, sir.
Yes,
Yes or
sir.
no? Okay. So this is something your PDF of y. I mean now it will take value 0 otherwise. Okay. So this is nothing but PDF of y. So the property which we have to keep in mind is nothing but we have to see whether the function is monotonic for x. I mean support of x. Okay. And it's a that gx is this gx is differentiable or not. Okay, if these two properties going to fulfill, then I'm going to use the this theorem directly.
Direct
Okay,
from.
this is the something we can see. Okay, now let's move to the when it's not the case. Okay, I think there is one example. Can someone tell me that? I think -3 1 is there, right?
Yes, sir.
Yes, sir. -3 1.
Something like that. Okay.
Yes, sir. Find the PDF of max of x comma 0.
Not max is something x square. Okay, x square is there. There was some post on Discord I have seen. I forgot the function. It should be in lecture.
-3 to 1, sir.
That's okay. What is function is x square, right? Function was x square.
Yes, sir.
Okay.
Like uniformly -3 to 1, sir.
Okay, fine. Okay. So we had x follows uniform distribution. Okay. -3 to 1. Okay, fine. And we had to find the PDF of x square. Okay, how many of you got this as the correct, or you got? I mean, you were able to understand the concept.
I'm not sure.
Okay, what about others?
No, sir. How the part?
Okay, I mean, you did not get. Okay, that is okay. Okay, let's see. Let's see. This is the yeah. Okay, let's see. This is this case. Okay, first of all, what is the PDF for this uniform? It will be 1 upon
1/4. 4.
For the this case,
-3
right?
to 1.
It will be
0
0
otherwise.
otherwise. This is something. Now, let's see. Let's draw the graph first of all. Okay. Just a second. We'll try to understand that this is the y. This y means I'm talking about x square. Okay. And this is the x. So basically, how your x will look like basically. Okay. Not x. I'm talking about. I mean x square. Okay. So this will be something. Your x square will be like this, right?
Yes.
Yes or no? And why I have drawn this like this? Because for the support of x,
For the range.
support of x is -3 to 1, right? For example, this is just assume scaling should be proper. Here I'm not able to do, but just assume this is -3, okay, and somewhere -2, okay. Then suppose this one is -1, and this one is 0 here, and this one is the 1, okay. So this will be dotted line. I mean, this will be the graph, but this red one or bold,
Not
bold
in
blue.
range, sir.
Hmm?
Not in range, sir. Not
Yeah, the
for
bold is in the range. Bold blue is
Yes.
the in range. Okay. Yeah, that is the see your x. See what is uniform -3 to 1, right? Yes
That
or
is
no?
point of interest.
Yeah. So -3 to 1 will be like this. Okay.
Yes.
Basically, x square graph will be your x square graph will be like this. Okay. But we are interested till here only, till one only. Okay. The previous example, if you see, okay, let me tell you one more thing here. Okay, tell me whether this function is monotonic in the given range, given support of x.
No, sir.
Yes.
No, sir.
No, sir.
Decreasing
No,
and
sir.
then
It's
increasing.
decreasing and increasing, right?
No, sir.
While in the previous, very first example which I took, if you see in this example, for x greater than 0, function was the same, x square. It was monotonic, right?
Sir.
Yes.
Now you can see the difference. Okay. Now, since it's not monotonic, I can't use the
Correct.
theorem directly.
Theorem.
Okay, I can't use theorem. So what we have to do? So I have to start with the CDF part. Okay, okay. Let me write down properly. Okay. So okay, this graph part is okay as of now. Okay, this scaling should be proper. I mean, this -1 and distance should be proper, but just see the things. So for support of x, which is -3 to 1, okay, my function, which is gx as x square, is not monotonic. Okay, basically. Okay, so first of all, what will be the support of y, x square?
Sir, 1 to 9, sir.
0,
Why
0
1?
to 9,
0 to
sir.
9, right? Lower limit it can take 0.
Yes, sir.
Yes or
0
no?
to
Yes, sir.
9.
0 is 9.
Okay,
0 to
fine.
9.
Now, so let's proceed. So what we have to do, we have to start with the CDF part, which is nothing but probability of y less or equal to y. Yes or no? Now, what is y? Y says x square less than equal to y. Okay. Now, so we have to split the case. Why? I will tell you. Now, we have to separate the region. Region means from 0 to 1. This red one, okay, this red curve, and sorry, let me see, y will be where to where? 0 to 1, sorry, 0 to 9,
Yes, sir.
okay, and 1 to 9. Basically, I have to replace, let me, okay, I will tell you what I'm saying, trying to say. If y belongs to 0 to 1, okay, so that means x square will be less or x square will be less or equal to y. This is something correct. This means, can I say minus y, square root of y less than x less than square root of y? If y, okay, let me tell you, if y is 0 to 1, if y is between 0 to 1, that means your x will be -1 to 1. Yes or no? Yes, are you getting?
Yes, sir.
See,
Yes,
why
root-wise.
I'm doing like this? Because I will tell you. So if y, see, if this is the case, x square less or equal to y, then x will be minus, I mean, square root of minus y, then square root of y, right?
Yes, sir.
So if y is 0 to 1, y will be 0 to 1 between from 0 to 1, then minus x will lie -1 to 1 or not.
Yes, sir.
Okay. What I mean, if y is 0 to 1, then this property will fulfill. I mean, this your y will be, let's say, minus square root of y to square root of y, because I'm talking about -1 to 1 here, right? Yes or no? In this plot, it will be there. Yes. Are you getting?
Yes, sir.
Now, if so this is the first case. Let's say I'm saying y belongs to 1 to 9. We have to see other case. So what will be x square less or equal to y? Now tell me, so this will be vice versa. So can I write minus y less or equal to x less than square root of y in this case, or something else? Just put any of the value.
Yes,
Okay, let's put the 9 itself in the place of y. Let's put 9 itself. So can I write here, if you put 9, so can I write -3 to 3 for x?
No, sir.
No, sir.
No, we can't, because this is the only this is the upper limit,
One.
right?
Yes, sir.
Correct. We
Yes,
can't
sir.
write this one. So what I will write, I will simply write minus square root of y to 1. Yes or no?
Yes, sir.
Are you
Upper
getting my point?
Yes, sir.
Basically, this part, yeah. Someone is saying something. Are you getting this idea, right?
Yes, sir.
Okay. So these two part is okay.
Yes, sir.
Okay. So let's see the case one. Case one is this previous one. This one. Okay. Now, so for this, CDF is Fy of y. So it will be probability y less or equal to y. This is nothing but probability of x square less or equal to y. Okay, so what is the thing here? So I can simply write minus square root of y less than x less than square root of y. Yes or no? So what I can do here, I can simply, can I integrate the PDF minus square root of y to y? That means which PDF? Fx, right? And fx is, I think, 1 by 4, right? Okay. Are you getting how I have written this?
Yes, sir.
Everyone is getting this point?
Sir, it was
Yes, sir.
0 to, sorry, -1 to 1, sir. So that
No,
in that
minus
case,
one.
2 by 4.
I took one particular case actually. See 0 to 1. Y can take any value, right?
Okay, sir. So in this case,
Yes,
1 by
sir.
4. Okay.
Okay. Okay. Here we have to be focused with this. Okay. Okay. This part is okay, right? If fx is something defined, let's say 1 by 4, then probability a less or equal to x less or equal to b. How I will do? I will integrate a to b fx dx, right? This is something I am doing.
Yes, sir.
That's correct. So it will be 1 by 4 minus square root of y to square root of y 1 into dx. It will be 1 by 4. So it will be x, right?
Yes, sir.
Minus square root of y square root of y. So basically I will get 1 by 4 square root of y minus of square root of y. So basically I will get 2 square root of y divided by 4, which is nothing but square root of y by 2.
Sir, if the range is symmetric, then we need not to
Yeah, then
split
it's
in
fine.
cases.
Yeah, then there is no need to split the case actually. Okay, I took this example
sir.
because on the discourse I saw one post regarding that. That's why I took this example. Okay, so this is
Thank you,
something
sir.
CDF part, right? Now, how will you compute the PDF from the given CDF?
By differentiating it.
By differentiation. Yes or no? Okay, we'll basically why? Because fx is what? Probability x less or equal to x, if this is the case. So how will you do? Minus infinity to x, I have to integrate the thing, right? Correct.
Yes, sir.
If you want to this PDF, so PDF is nothing but how will you do in reverse order? Reverse thing is you have to differentiate the CDF, you will get the PDF. Okay. So I got the CDF for the very first case, okay, which is square root of y by 2. Okay. So what I will do here, I will differentiate to the PDF. So fy of y will be basically d of dy f capital Y of y. So this is the case 1. So d of dy into square root of y by 2. So I think what is 1 upon 2 root y, right? So it will be 1 upon 2 into 2 root y.
Yes, sir.
Am I right? Right? Yeah.
Yes, sir. You're right.
Yes, sir.
So fy of y I got as 1 upon 4.
4.
4
Now tell me
root y.
what is the support of x here? 0 to
1, sir.
okay. This is the case 1. We have to see the for case 2 as well. Okay. So for case 2, it's the 1 to 9. So case 2, probability that y less or equal to y, which is probability x square less or equal to y. And for this case, we got minus y less than x less than 1. Okay. Then I have to difference, sorry, not integrate from y minus y to 1. And PDF for x is 1 by 4, right? So it will be 1 by 4, 1 minus square root of y. So from here I got 1 by 4, 1 plus square root of y. Yes or no? This is the CDF part. Okay. So what will be the PDF? PDF is nothing but differentiation of this part itself. So what will be the differentiation? It will be d upon dy. Okay. 1 by 4,
8 root y.
1 plus square root of y. So it will be 1 upon 4 into differentiation of 1 plus square root of y. It will be 1 upon 2 root y again. So fy of y will be 1 upon 8 root y for the region 1 to 9. So basically we got the distribution of f y, which is nothing but 1 upon 4 root y for this case. and 1 upon 8 root y for this case. Okay, is that all right?
Sir, I have
Yes.
doubt. Like in case one or two, you simply split the function in range, like -3 to 0 and 0 to 1. Am I right, sir?
-3 to 0 or 0 to 1? Yes.
Yes, sir. In
-3 to 1, right?
-3 to -3 to 1.
One second, one second. Here we got -3 to, see, we have split it 0 to 1. Okay.
0
So
to 1.
-3 to 0, then 0 to 1.
Okay.
Right. That is something you are asking, right?
Yes, sir.
Okay. Yeah. So let's do one more thing. Okay. Let's see whether it's monotonic or not. This is the case. Okay. Let's do. Suppose question is.
Sir, one doubt, sir, in this.
Yeah. Please go ahead.
In range, sir, this is why not from -1 to 1, sir? This is 0 to y is between 0 to 1.
Why not -1 to? See, y is x square. See, y is your x square and x is -3 to 1. Okay. See, this function. Okay, tell me, y is x square. This is your function, right?
Yes, sir.
Correct. This is something. And if x is -3 to 1, what will the y equal to x square? First of all, tell me.
0
Are you
to
getting?
9 to 1.
No, why you are taking
0
1?
to 9.
0 to 9, right? Okay. That is something I have taken. Okay. Fine. Clear, right? Yes, no. If you are not, you will not say something other. How will I get the idea? Okay.
No, sir, we are not good.
Sir, hello.
Yes.
In case
Sir.
in case 1 and 2, sir. Like how you split the function y for y belongs to 0 to
Okay,
1.
first of all, see, we can't generalize this case. Okay, if you write this one, you cannot write this case always. Okay, because if you see from 1 to 9 itself, right? After 1 to 9, you can't write this one, right? -1 y. If you, okay, first of all, if your y will be 2, can you write by seeing this graph? Can you write your x is lying between -2 to 2?
X is between 2 to 2.
Can you write? First of all, tell me.
No, sir.
You can't, right? That's why we have to split the case. See,
Sir,
okay, first of all,
sir, can I ask you something?
okay, one second. If I'm
Yeah.
going to write with the CDF part, right? So you are saying x square less than y. Y I have not simply written -y to y, right? And y I have not. Suppose this is the case, I will get in general. Okay.
Yes.
Correct. Y is from 0 to 9. We have to see whether this case is true for all. No, it's not true, right? If you y will be 2, so can you say your x is -2 to 2?
No, sir.
You can't say, right? That's why I split it 0 to 1 and then after 1 to 9.
Sir, did you split 0 to 1 because it is symmetric from -1 to 1?
Yes. See,
Okay.
if you see from 0 to 1, if you see 0 to 1, any value you will take, whether 0 or 1 or 0.5, it will always be from here to here, right? From this rate to this rate. Yes or no? Between this rate to this rate.
Yes, sir.
Correct. If your y will take after 1, suppose y you substitute 2 or y is 9 or 3, you can't write this case always, right?
So there we have to write the restriction.
Correct. So we have to write the restricted one, which is upper limit will be 1. I mean, suppose I'm saying y is 9, for example. So you can't write this case or in general, because if you write this case, that means you are going to write -3 to 3, but which is not true. We have to write -3 to 1. Okay, and this -3 is nothing but minus of square root of y. The same thing I have written here. Is this clear now? why we have split it, why we are splitting here?
Yes, sir. Clear, sir.
Yes, sir.
Fine.
Yes,
Now,
sir.
so we have to be little. Okay, for example, suppose limit is -3 to 3. For example, suppose 3. Then you can do in a single PDF. It will be there. Are you getting?
Yes, sir.
Yes, sir.
Because if you okay, if -3 to 3, if you are going to put any value of y, it will always be true. Right? Got it?
Yes, sir.
Yeah. So I was going to take some other example. Okay, let me take that one. Suppose
Sir,
I'm
can
saying
you solve the same question with taking y is equal to mod x?
mod x. Okay, I'm going to take some mod example. No worries. Okay.
Okay, sir.
The same thing. In mod, we have to identify the area also, right? Which one is the correct or which one? I mean, whether it is going to true or not. Okay. Don't. Suppose I'm saying it's a -3 to 3 is there, for example. Okay. Then suppose PDF of y equal to modulus of f. This is something. Okay. Now, if this is the case, tell me what is the PDF of x? It will be
0 to 3.
PDF of x.
1
by
upon
6.
6. 1 upon 6.
Okay. So support is -3 to 3 and 0 otherwise, right? This is the f of x. Now, how will you, okay, what graph, what something graph will look like of this x? It will be something. Sorry. For the graph and all, you can simply use the Desmos, right? Have you ever heard about Desmos GeoGebra?
Yes, sir.
Yes, sir.
So you can use.
Yes, sir.
Okay, actually this should be just see the line in clear way. I'm just trying to explain here. Okay, so this is your y. Okay, now x is -3 to 3. Correct.
Yes, sir.
Okay, so
Yes, sir.
basically it will be like this. Minus x is -3 to 3, and this basically this line is, this is the 1/6 as per this uniform distribution, right?
Yes,
Now
sir.
tell me, for this support of x, whether y equal to mod of x is monotonic? It's not monotonic, right?
No, 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 sir.
If it's suppose, okay, tell me if x is 0 to 3,
Then
then
it is monotonic, sir.
in the monotonic, I can use the theorem directly, but here I can't. Okay, it's not monotonic, so I cannot use theorem directly. Okay, so how will I proceed? I will proceed with the CDF part. Okay, so Fy of y will be probability y less or equal to y, right? So that means probability, I have to replace mod of x less or equal to y, right? So it will be probability, I can simply write minus y less or equal to x less or equal to y, correct?
Yes, sir.
Okay, so here, okay, is there any restriction on the range of y? No, right?
No, sir.
Correct. Okay, what will the limit of y from here?
0 to 9.
0 to 9?
3.
0 to 3 is a modulus, it's not about square, okay?
Yes, sir. 0 to 3.
So it will be minus y to y, I have to differentiate 1/6 dx, it will be 1/6 minus y to y, 1 into dx, 1/6, 1, sorry, x, y to minus y. So it will be 1/6 y minus of minus y, just putting the limits. It will be 2y divided by 6, which is nothing but y by 3. So this is the CDF, right? And how I'll get the PDF? So PDF is nothing but differentiation
Differentiate.
of the CDF part. So it's a 1 by d of dy into y by 3. So it will be 1 by 3 itself, right? Because differentiation, basically you will get this case, right?
Yes, sir.
It will be 1. So Fy of y will be 1 by 3 for the support 0 to 3. Is this clear? Yes. By saying this, can you tell me what is the distribution of y?
It will be a uniform distribution.
It's a uniform, right? It is uniform 0 to
Yes,
3.
sir.
Yes or no? That means modulus of x is following
Yes, sir.
uniform 0 to 3. Is this clear?
Once again, how you did it, sir?
Which one?
Like you don't split the functions like.
Is there any need to split the function? First of all, tell me. If you will put any value of y from 0 to 3, it will always be true, right?
Yeah, sir. I got it, sir.
Now it's clear. Okay,
Yes.
let me tell you that case, the splitting. Maybe you will get some clear idea. Okay, just give me a minute. I think you guys are getting difficulty for splitting, right? Don't worry.
Yes, sir.
Okay, suppose I'm saying x is uniform. Okay, -3 to 2. Now it is not -3 to 3. Now I'm saying I'm just going to the CDF. Okay, just if you will differentiate, you will get the PDF. Okay, I'm not going to differentiate. Will that be all right? Okay, so I will physically
Yes, sir.
Yes, sir.
focus on when to split or not. So here fx of x will be how much?
Sir,
Yes.
sir, put your PC on the charge, sir.
Oh yeah, thanks. Okay, just give me a minute. I will take my charger. So this is the
Okay, sir.
PDF, right?
Yes, sir. This is
Okay.
PDF.
Just
Yes,
give
sir.
me a minute. I will be back in 1 minute. Okay. Meanwhile, you can solve that question. Hope let's see whether you got it.
Okay, sir.
Okay. So are you able to do it? Yes. No. Okay. Let me. Okay. Should I proceed or should I wait? If you are doing, then I can wait. No problem.
So proceeds.
Okay, no problem. Okay, so what is the graph of mod of x first of all? How does it will look like?
V shaped from the origin and upward.
Okay. Uh, 1 second. So it will be basically scaling in a proper way. Okay, just treat that is the proper way. Actually, it's okay. Just treat at the center. Okay, well, hopefully you got the idea. Okay, I'm just trying to explain here. Okay, so what is the range of x? -3 to 2. Okay. Just scaling. Okay, so are you getting what I'm trying to here draw, right?
Yes,
Yes.
sir.
Yes, I'm not able to draw properly here, but let's try to discuss the splitting and all. Okay, so if this is the case, why is okay? This modulus x is not monotonic, right here, correct?
Yes, sir. Yes.
For x,
Yes.
right? So that means I can't use the theorem. I have to proceed with the CDF part. Now, if you see x is -3 to 2, right? Then what will be the support of if y is equal to mod of, then what will be the region of y?
0 to 2.
0
0
to
to 2. 0 to
2.
0 to 2,
0 to 3, sir.
0 to 3, right?
Yes.
Well, it's a
So Y3,
-3.
sir.
What is this?
Okay.
Okay, sir, got it, sir.
Got it? Now, if
Okay.
you see, okay, so first of all, let's do. So what is the f of y? So this will be probability of y less or equal to y, right? And what is the y? Modulus of x less or equal to y. So it will be probability minus y of x less or equal to 9 y. Now we have to stop here. In the previous case, it was -3 to 3, right? If you see -3 to 3, if you will put any value, this case will always be true. Now is this case here? If you will put, okay, if I will put any value from 0 to 2 for y, it will always be true, right? Let's say I'm putting 1. I will always get -1 to 1,
Yes, sir. Yes, sir.
or -1.5 to 1.5,
Hmm.
or -2 to 2, right?
Yes, sir.
Correct. But because upper limit is 2, right? If you have to little bit careful. But after 2, if I will put, let's say 3, can I get -3 to
No, sir.
3?
No, sir.
We can't get, right? So it will be -3 to
Yes, sir.
2. Correct. Now you got the idea. So your case 1 will be, okay, case 1 will be your y is belongs to 0 to 2. Okay. Then your modulus of x is less or equal to y will become how much? It will be basically, then I can write minus y less or equal to x less or equal to y always.
Yes,
Yes
sir.
or no? For this
In
case, correct?
region 0 to
In this
0
region.
to 2.
But for case 2, if you see, for y 2 to 3, okay, this modulus of x less or equal to y, it will be minus y less or equal to till 2 only. Is this clear?
Yes, sir.
Yes, sir.
Okay. Now you are getting how we are splitting, right?
Yes, sir.
Okay. Now, so we have to find the for case 1. Okay. So probability that, I mean, fy of y is nothing but probability of y less or equal to y, which is nothing but, I can simply write modulus of x less or equal to y, right? So it will be probability that minus y less or equal to x less or equal to y, and this is the true for that case. So I have to integrate minus y to y and 1 by 5 dx, right? It will be 1 by 5 minus y, sorry, should be y actually, minus y to y, 1 into dx part. So it will be 1 by 5x minus y to y. It will be 1 by 5 y minus or minus y. It will be 2y by 5, right? Correct?
Yes, sir.
For this case, okay? So which is fy of y, okay? Now case 2 is when y is after 2 to 3, right? So fy of y will be again, so probability of y square less or equal to y, and probability of modulus of x less or equal to y. Now I can't write this. I will write minus y to x less or equal to 2, not 1. Okay. So minus y to 2, 1 by 5 dx. So basically it will be 1 by 5, 2
No,
minus of y. It will be 2 plus y by 5 for the,
हाँ 17 रुपए आता है.
I think, yeah, thanks. Okay. Now is this clear, right? So basically we have uh, two PDF. Okay, I mean not PDF, CDF. What are those? First is 2y by 5. Okay, for the support when 0 to 2, and then 2 plus y by 5 when 2 to 3, right? And before 0, normally we are defining it's a 0, and after 3 it will be 1. Now if you will differentiate, you will get the PDF part. Is this clear? Splitting and all? Okay.
Sorry, sir, but for some time I
Yes,
did
sir.
not I did not hear, sir. So can you explain, sir, case 2, sir?
Yeah, you were talking to someone at your home, right?
Yes, sir.
Okay, so be ready with here. Okay, where you got the, basically the same thing we have repeated. The procedure is the same. Just splitting part is okay or not? Okay.
Okay.
So
Yeah,
the
is
same thing.
splitting part okay, sir?
Yeah,
Oh.
the same thing for this support, for this given
Minus.
range, we have to integrate. That's all. Okay.
Okay.
Fine. Okay.
Sorry,
So yeah.
can you go a bit up in the
Okay.
slide? There is somewhere written here, f of y equals to p of y square smaller than y. So I guess it should not be y square there, or I'm.
Oh, yeah, correct. It's by me. It's a y actually. It's a random variable. Yeah.
Yeah.
Yeah, it's a random variable. Okay.
I will,
Yeah, it's a random variable. Yeah.
Yeah, that's it, sir. Thanks.
Yeah. Okay. Thanks.
Sir,
Yes.
sir, in range 2 to 3, Why you put minus y to 2, sir? Yeah, minus y to 2, sir. Minus y to 2. Why? How it is minus y, sir?
How it is minus y?
Yes, sir.
Great. Okay. Tell me, how can I write modulus of x less or equal to y as a minus y
Yes,
of
sir.
this?
Yes, sir.
Correct? The same thing I have written there?
Hmm.
Yes or no? The same thing is there. Minus y to 2. If you are talking about y2, the splitting is there, right? Can x take beyond 2?
No, sir.
That's all?
No, sir.
Okay. So if your y is from 0 to 2, right? If you'll see, then x will always be true, correct? If y is 0 to 2. If you put any value, it will always be true. Yes or no? Minus
Yes,
y to y, correct?
sir.
If y is 2 to 3, let's say 3, x can't exceed. So x always be minus y to 3. Sorry, 2. Okay?
Yes.
Okay.
Yes, sir.
Now, okay, so far so good. Clear for everyone?
Yes, sir.
Okay, yeah. So let's move to the next topic, which is called expectation. How many of you covered till expectation?
Yes, sir. Covered.
Okay, I think expectation is the easy one, or any doubt? Meanwhile, I will go the concept. I will go expectation of continuous random variable. Okay. So in discrete case, okay, in discrete case, how we have done? We had discussed like, okay, for a discrete, suppose x is discrete random variable, okay, with PMF. Then expectation of x, how we are defined, we have to summation x into probability
Marginal
of
and
x equal to x, right?
yes.
Right? If suppose gx is the function of your random variable, then how will you define expectation of gx?
Gx into
Summation of
probability of x
gx
equal to
into
x.
respective probabilities, right? This is
Yes, sir.
something we have done in case of discrete, correct? In case of continuous, let's see, the only thing is we are actually in continuous. If you attended the week 4 open session, so integration is nothing but it's a continuous summation, right? Okay. So let's say x is a, I'm saying, continuous random variable with PDF fx. Okay. Then expectation of x is nothing but we have to replace this summation sign with the integration. It will be integration of x into PDF of x dx. Okay. Yes or no? So minus infinity to infinity means range of your support of x. So one thing is we have to keep in mind this integration should exist. I mean, it shouldn't be uh, converged to plus infinity. Okay. I mean, it should be less than infinity. Means we should get some finite value. Okay. If this is the case, if gx is any of the function of any function of x, then the same thing I can do gx into fx of x dx.
Yes, sir.
Correct? Are you getting the idea behind this? Right?
Yes, sir. In the continuous random variable, we have to integrate.
Yeah,
In
we
the
have to
discrete, we
integrate. We
have
have
to
to replace
summation.
it. Yeah, yeah. Correct, correct, correct.
Yes.
Okay, tell me, what about variance part? If you see how we are defining the variance of a random variable, it's nothing but expectation of
Expectation of
x
x
square
square
minus expectation of x whole square.
whole square.
So from here, this star part, you can calculate expectation of x, right? For expectation
Yes.
of x square, what is this? This is x square, nothing but function of your random variable, right?
Gx. Yes, sir.
So basically, this expectation of x square, I can calculate, I can integrate minus infinity x square into PDF of your random variable. Yes or no?
Yes, sir.
Yes, sir.
Clear? Something? Okay. Okay, so there are some, mean, sorry, expectation and variances of some distribution. Okay. So we can go or we can find that one, not a problem. Okay. So, or else, let
Same
me,
from the.
sorry.
These are same from the stats one also, and some are from the before week 1 to 4. Markovs and the Chebyshev are same.
Yeah. So Markov and Chebyshev are in week 5, right? No, it's in week
No, sir,
3.
in the week
Week,
4.
week
Yes, sir.
3 or 4, sir.
Week 3 and 4 it was there, right?
Yes, sir.
Yes, sir.
Okay, so this is something expectation you can find, right? Should I take any example or it's fine? Let me tell you some for about distribution. I think this is something clear, but let me tell you. Suppose X is following continuous uniform distribution from A to B. Okay, then what is the expectation? Anyone can tell me? And what is the variance? And what is the support of X? What is the support of X first of all? It's A to B.
Yes, A to
And
B.
what is the expectation of in this case? Anyone can memorize?
B minus
Sir,
A,
A plus B
A
by 2, sir.
plus B upon 2. Yes.
And what is the variance?
B minus A to the
B
whole square upon
B
2.
minus a whole square by 2.
Right? In case of, if you see, I'm saying following exponential with parameter lambda, then what is the support? First of all, it's x greater than 0, right?
Yes, sir.
What is the mean?
Yes, sir.
1 by lambda
Lambda.
square.
What is
1
the
upon
variance?
lambda.
Lambda
1 by
square.
lambda square,
1
sir.
upon
Okay,
lambda square.
let's do for uniform. Maybe you will get some idea. Suppose I'm saying x is following uniform a comma b. Okay, then what is the PDF? PDF is nothing but 1 upon b minus a, right? Which is a. I mean, your x will be from A to B. Now, what is the expectation of
PDF
x?
or, sir?
It's a
Yes, sir.
PDF.
PDF. Yes, sir. It is
The
PDF.
expectation is nothing but x into fx of dx, right? We have to integrate throughout the range of x. So what is the range of x here? I mean, support of x, A to B.
B.
X. And what is the PDF? 1 upon b minus a dx. Yes or no? Right? So 1 upon b minus a, I can take outside. I will get A to B x into dx. Right? So it will be basically 1 upon b minus a x square by 2, right?
From A to
A to B. So 1 upon 2b minus a. So if you see, I will get b square minus a square, right? If you will put the limit, correct? Yes or no?
Yes, sir. It is.
Yes.
Clear,
Yes.
right?
Yes.
So this b square minus a square, I can write b plus a, b minus a,
Yes, sir.
right? 2 times of b minus a will get cancel out.
Yes,
A
sir.
plus B by 2.
What I got? A plus b by. Now you got from where expectation of x is coming out to be a plus b by 2.
Yes, sir.
Okay, same you can find for the variance. So to calculate for the variance, what you have to calculate the expectation of x square. Okay, because see, anyway variance is what? Expectation of x square minus expectation of x whole square, right? You have expectation of x, you have to calculate expectation of x. It will be x square into 1 upon b minus a dx. Just do this and you will get to the answer. I mean, you will get variance as a b minus a whole square divided by 12. Okay, this is something we can do. I mean, procedure is same to find for the exponential distribution or any kind of PDF is given to you. Okay, all right.
Yes, sir.
Okay, so there is one more. I think it's last lecture video. I think is there anyone who have completed the last lecture video?
Yes, sir.
Okay, Sudhir, right? You have completed. What about others?
No, sir.
If you ever not, it's not a problem. I will explain. I will try to explain the concept. Okay. No problem. Okay. So till now we have seen that 1 minute. Sorry. We have seen the function of continuous random variable expectation, and similarly we can find the variance. And now what about joint distribution of if one is the discrete and one is the continuous random variable? Okay. Let me try to explain some concept first of all. So topic is joint distribution of discrete and continuous random variable. Okay. Okay. Meanwhile, can you apply this? If suppose this is the case, can you apply the Chebyshev inequality and all? Because you have to, rather than adding and all, you have to integrate the thing. Basically, okay. Right? Are you getting my point? Suppose what I'm saying, x is greater or equal to c, less or equal to mu by c. Okay. Then if you know the expectation of x, if this is the case, right? X is greater or equal to, let's say 2. Then you can calculate the expectation of x for that distribution and divide by 2, right? You can find the bound.
Yes.
Okay, the same thing we have to do. The only
Sir,
thing we have to keep in mind, we have to integrate, not summation.
sir,
Hmm?
Markov and Chebyshev also applicable for continuous random variable.
Yeah, it is applicable for any kind. The same thing I explained here.
Oh.
See, suppose x is a continuous random variable, right? It is greater or equal to some constant. This is mu is what? Expectation of x, right? This expectation of x, if it is discrete, how you can computing summation of x px, right? Which continuous, I have to integrate x fx. That's all.
Yes.
Got it? Yeah. So let's focus on this part. Joint distribution of discrete and continuous random variable. Okay. So what is that? Before this, I will try to I will ask you some question. Tell me, uh, have you remembered that law of total probability?
Yes, sir.
If you have two event, let's say I have two event. Let's say this is the A, this is the B. Okay. Some another sorry. Let's say this is the B1. Okay, and this is the B2. Another event A is something like that. Then what is the probability that A? What is the probability of A? Okay, so probability of A is nothing but I will say probability of A intersection B1, right? This part plus probability of A intersection B2, this part, right? This is
Yes.
something I can calculate this one, yes or no?
Yes, sir.
Correct?
Yes, sir.
And by the multiplication rule, can I write this one as probability of B1 into probability of A given B1 plus
Yes, sir.
probability of B2 into probability of A given B2, right?
Hmm.
Yes or no? I can write this one.
Yes, sir.
You know this multiplication rule. See,
Yeah.
I have probability of, if you are not recalling, just tell me. This thing I can write this like this, right? Yes or no? Conditional probability. Now from here I can write this one.
Yes,
Correct?
sir.
Okay.
Yes, sir.
So this is called multiplication rule. Okay. Now let me focus on the property. Suppose I'm saying x and y. Okay. Basically, let's say I'm saying x is discrete random variable. Okay. With range, let's say tx. Okay. And let's say PMF is probability x is x. Okay. Okay. This is the case. If it's general, can I talk about summation of I probability of bi into probability of a given bi, right? I mean, I can be 2, 3, 4, anything.
Yes, sir.
Correct? No. This is the case. Now, so what is the meaning? Suppose I'm going to say here for each x. Okay. For each, this x belongs to this range of, I mean, this is going to take value in this range. Okay. Suppose I'm saying we have a continuous random variable y of x. Means if you'll put the value of x in this PDF, okay, with density fyx of y, means for each x it is defined. Okay, don't worry, I will take the example, maybe that will give you some idea. Okay? Now basically, okay, what this yx meaning here? So this yx is not about uh like marginal PDF. This means I'm saying for each x, means I'm saying y given x equal to x. Okay, means I'm saying y given x equal to x. So I'm talking about you have a discrete random variable. Okay, it is with some range and with some PMF. I'm talking about for each x there is a continuous random variable which is defined as like this. Means you have information about this case, this conditional, and you have information about the marginal of x. So far so good. Yes or no? So basically,
Yes, sir.
I'm if I will write fyx of y here, so this means I'm talking about conditional distribution of y given x equal to x. Okay, or this is the same as notice means probability of y given x equal to x at y. Okay, this is the same thing I'm talking about. Okay, so far so good.
So
The
it is a different notation, sir.
yeah, just a different notation. Try to understand. X is given to you, and for each x, given that x equal to x, there is a conditional distribution is defined. I mean, given to you, y given x equal to x. Okay.
Yes.
Now, question is how to find the distribution of y. If I'm talking about marginal density of y. Okay. So how will you find?
Sir, summation of all I uh, xi,
Okay.
sir. Xi.
Okay. If you
For all
see,
xi, sir.
if you see, this is something I can talk about. This is about marginal,
Yes,
discrete
sir.
of marginal, correct?
Yes.
And this is the conditional.
Hmm.
Can I say yes or no?
Yes, sir.
If you compare, so this conditional is given to you, and this marginal is given to you some PMF, right? So
Yes.
how will you find the marginal density of y? So it's nothing but I have to add throughout the x, means throughout the I. What
Yes.
is I? So it's a px of x, right, into fy given x equal to x. Okay, basically it's nothing but summation of probability of bi into probability of a given bi for each I. Now, are you able to relate this?
Yes, sir.
Basically, this is nothing but probability of x equal to x, and this is nothing but your density of y given x.
Given xi.
So far, so good. Formula is somehow you are able to relate.
So can you please explain this formula again?
Okay, basically, the here we are going to use the marginal density of. I mean, sorry, we are using to find the marginal density of continuous random variable y. We are going to use the law of total probability concept. Okay, how it will be basically. So see, if you see the law, okay, this law of total probability is okay. Or should I explain again?
Explain again.
Fine. So you could ask at the same time, right? If you are not getting the things, okay? Rather than okay, no problem. Suppose I'm saying I have two events. I'm going to explain the law of total probability. If you have two events, let's say B1 and B2 like this, and there is another event, this circle A, then what is the probability of A? So this probability of A, I can define probability of A intersection B1, right? This shaded region, or
Yes, sir.
addition of probability of A intersection B2, like this lines, right? This probability of A intersection B1, I can split like probability of B1 into probability of A given B1 or not by the multiplication rule. I mean, this is called the multiplication rule. Okay, right? Yes or no?
Yes, sir.
Similarly, probability of B2 into probability of A given B2. So this thing I can write in general is some sign of the summation of I, probability of Bi into probability of A given Bi. Correct?
Yes, sir.
This I
Yes, sir.
can be 1
Yes.
to 2, 1 to 3 anywhere. Okay, I'm talking. So the same thing we have to apply. Suppose x is the discrete random variable is given to you with range x, tx. I mean, you can assume this is the let's say x equal to x1, x equal to x2 is given to you, something like that. Okay. For that, one conditional you have been given to you, y given x equal to x. Okay, the same concept I can apply. Then marginal density of y will be, if you see what is this, this is the marginal of bi's, right? Okay, this is a marginal, and this is the conditional
Yes.
probability. So I have given the marginal PMF of discrete and conditional distribution of y when x is something. I mean, for a given a value of x. Okay, basically this will be given to us, and this will be given to us. So question is how I can find the marginal density of y. Then fy of y will be summation of, you can say this is the marginal, this is the marginal of x, and this is the conditional probability, and this is the conditional. We have to basically substitute the find the, I mean, we have to For each x, we have to find the conditional distribution of y. Okay, is this some rough idea? Is okay? Okay,
Yes.
some rough idea. Okay.
Yes.
I will tell you something. Suppose one example is there. Okay, it's I think it was normal. Someone can tell me that one. It's from lecture video itself. Okay, I think let me try to recall so that you can get the idea. It was something. Suppose x is following uniform. Okay, I think it was some 0, 1, 2. Okay, and y given x equal to 0. Okay, was someone can check. It's I think it's in last lecture. It should be lecture 5.4. Can you check the values?
In which, sir? 5.1.
5.4, 5.4. It's not 1.
Acha.
Basically, so this all should be given to us normal. Okay, and y given x equal to 2 normal. Okay, and there should be some mean and variances. Did you get it? Let me open.
Sir, y given, sir,
Yes.
y is equal to x given is equal to 0 normal. 5 to 0.4, sir.
Okay, okay, fine. So you are saying it's a 5, 0.4. Okay. Then y given x equal to 1?
For 1, sir, normal 6 to 0.5, sir.
6 to 0.5. Okay, so I think this 0.5 is a standard deviation. 0.5 square should be there. Okay. I think next one is 7 then, right?
Yes, sir. 7
Fine.
or 0.6, sir.
Okay, got it. So if you see, if this is the case, okay, suppose these all things is given to you, okay, and then question is, what is the marginal of y? Okay, marginal PDF of y. So if you see here, from here I can find the discrete, right? Means what is the probability of x equal to 0? It's 1 by 3.
Yes, sir.
Probability of x equal to 1, 1 by 3.
3.
Probability of x equal to 2, 1 by 3, right? So if you see, marginal is given to us, I can find into conditional is given to us, means for each x equal to 0, y given x equal to 0 is following normal distribution. Same, y given x equal to 1 is following normal distribution, and y given x equal to 2 following normal distribution with this parameter. Okay, this is the information is given to you. So how will you find the fy of y? Is nothing but we have to add throughout the range of y p probability of y equal to y into conditional distribution of y equal to x of y, right?
Sir, summation over x is equal to all value, all possible value, like 1, 2.
Yes, sorry. Yeah.
Yes, sir.
Thanks. It should be x because x is given to us, right?
Yes,
so it will be throughout the range of x probability x equal to x. So if you see, so basically what we have to calculate is probability of x equal to 0 into fy of given x equal to 0, then y plus probability of x equal to 1 into fy given x equal to 1, 2y plus probability x equal to 2, fy given x equal to 2, 2y. Yes or no?
Yes, sir.
Yes, sir.
Right? This is something we have to calculate, right? So basically we have to just substitute the values. I mean, it's a 1 by 3 into what is the PDF of y here? It will be 1 upon root 2 pi sigma. So sigma is 0.4. Okay. And I mean, it will be e raised power minus y minus mean is whole square upon 2 times 0.4
sigma square.
sigma square. Same plus 1 by 3 into 1 upon root 2 pi 0.5, right? Into e raised power minus y. Basically, we have to just substitute the values here, okay? Same for x equal to 2 here, okay? So this is something we have to do. I mean, the conditional is given to you and you have to find the like marginal of, okay? Is this clear?
Yes, sir.
Fine. Okay. Now, suppose, okay, let me, okay, you guys will tell me now. I think this would be the very easiest one. Suppose I'm saying x is uniform, okay? Let's say x is uniform minus 1 to 1, okay? And then I'm saying y given x equal to minus 1 is again uniform, okay, which is minus 2 to 2. And y given x equal to 1, let's say I'm saying it's a exponential which is with parameter 5. Now, I'm going to give you some 5 peanut. Just tell me what is the marginal distribution of or marginal density of y, because y is the continuous random variable. Tell me, okay? If you get the final form, just let me know. Okay, everyone has the pen and paper right now, right?
Yes, sir.
Okay, yeah, just,
Yes, sir.
you can take some 4 to 5 minutes.
Sir, we have to calculate the probability of from the -1 and 0 then 1 na? And add
Y0,
-1, 0 and 1.
Y0. X is discrete uniform here. It's not about continuous.
Okay, sir.
Yes, are you able to do it, right?
Sir, I solve it, but I don't know if it is wrong or correct.
Okay, no problem. Just if few of you, once you are done, just let me know. We'll discuss.
Okay, sir. Can I tell my answer, sir?
Okay, just tell me what the final form you got.
Sir, I got, sir, 1 by 2 into bracket 1 plus 5 into e to the power minus 5.
-5.
Yes, sir.
Okay. Uh, is there anyone who is trying? Yes, no, any? So if you're trying, you can let me know. If you're not trying, still you can let me know. Not any problem.
Sir, trying, sir.
Okay. Fine. Yeah. You can take some 2 to 3 minutes and do let me know, because see, I'm giving because you can get the some idea whether you are getting the concept or not, or where you are making mistake, something like that. Then you should take that much time. Okay. Anyone is getting any answer?
Not getting, sir.
Not really. What about this? 1 by 10 plus e raised power minus 5. Okay, let's see. Don't know the answer here. Okay, let me see. Okay, first of all, tell me what is the, this is the discrete uniform. So probability at x equal to minus 1 will be 1 by 2, and probability at x equal to 1 will be 1 by 2, right? Okay. So basically what we have to do to calculate the marginal density of y, we know what we have to do. We have to add the things throughout the range of x, right? Probability x equal to x into conditional probability, right? This is something we have to do, right? Conditional is given to me for each given x equal to minus 1, and this is the marginal is also given to me. Basically from where, if you see what is the support of x, minus 1 and 1. So x equal to minus 1 into f y given x equal to minus 1 of y, right? Plus probability x equal to 1. So just we have to split the this summation sign. Probability x equal to 1
Yes.
into f y given x equal to 1 of y, right? So what is this? This is 1 by 2.
Half.
And
Yes.
what is
Yes,
this?
sir.
Before.
1 by 4, because it's a continuous uniform. So continuous uniform is 1 upon b minus a, right? It will be 1 by 4, right? It will
Okay,
be
sir.
1 by 4 plus this is 1 by 2, and this is now,
Half,
it's
sir.
not a uniform, it's a exponential. It should be 5 e raised to power minus 5 lambda, right? So this would be the answer, okay? Not y, sorry, lambda, it should be y. Actually, it's a lambda x, so lambda we have 5, it's a y. Okay, is this clear?
Yes, sir.
Okay, so
Y
just
is 1, sir.
sorry,
Y is 1. No.
no, y is not 1. We have to find the this one. Okay,
Okay, Y. Okay.
y we have to. Now, so we have seen that, I mean, we have seen this probability of A as summation of I, probability of Bi into probability of A given Bi, right? Okay, before that, we have seen probability of A as a probability of B1 into probability of A given B1 plus probability of B2 into probability of A given B2. Now, this was the law of total probability. Now, maybe you have seen the Bayes rule, right? Bayes theorem, basically.
Bayes theorem.
Okay. What is this Bayes theorem tells us? So, in case of Bayes theorem, if I'm talking about, if I'm saying A is given to me, then what is the probability that it is from B1, right? So, how you can calculate this one as probability of uh, B1 given A divided by probability of A, right?
Yes, sir.
That means in the numerator part, I can say probability of B1 into probability of A given B1 divided by probability of A, right? This is something I can calculate the base rule, base theorem.
Yes. Yes.
Yes or no?
Yes, sir.
And what is the denominator part here?
Probability of A, sir.
Sorry, and what is that probability?
Sir, in denominator, sir, A, sir, probability of A.
I mean, probability of A means, okay, now if you see, suppose I'm saying, now I have information X is the discrete, right? Correct?
Yes,
And
sir.
Y is the continuous, correct? Now, so can I say instead of probability, now can I find probability of, what is the probability X equal to Y, given that Y equal to Y naught, I mean, for a specific value of Y.
Okay.
So can I write this as, what is this? Marginal of B1. So can I write Px of X?
Yes, sir.
Into, this is the conditional probability. So can I write conditional probability of continuous to see discrete one, this one? Yes or no?
Yes, sir.
And divide by, what is the P of A? This is the, if you see, P of A means we are talking about marginal of
Y, sir.
Y, continuous one, right? So basically Fy of Y naught. Is this clear?
Yes, sir.
How we are writing? So basically this Fy is nothing but marginal density of Y. So from here, okay, so see, if question is marginal density of Y, then I can use directly this one, correct? This method, correct? If question is reverse order, I mean, suppose what is the probability that X equal to X given that Y, then how will you proceed? So we can find this by the base theorem itself and by applying the base theorem. Let me tell you that one. This example, this exponential one, we have discrete, we have this case, right? What if I will ask, okay, so let me write down the cases again. X was discrete uniform minus 1 to 1, and Y given X equal to minus 1 was uniform minus 2 to 2, and Y given X equal to 1 was uniform, not uniform, exponential 5, right? Now, we have calculated the marginal density of Y, summation of X over Tx, probability X equal to X into Fy given X equal to X, right? This is something we have calculated the marginal of Y, right? Yes or no?
Yes, sir.
Basically, what we got? We got 1 by 2 into 1 by 4 plus 1 by 2 into 5 e raised to minus 5y, right?
5. Yes, sir.
Now, what if, so, okay, so this is the given to us, this is given to us, this is given. What if I will change, what is the probability that X equal to minus 1 given that Y equal to minus 1? Correct?
Yes.
If this is the question, then how will you proceed? Can I find the now I can apply this theorem? Yes or no? Means
Yes.
you to X equal to minus 1 given that Y equal to minus 1, right?
Multiplication theorem in reverse order, sir.
Not in reverse order here. See, here we are applying the base theorem.
Base.
Okay.
Yes, sir. Yes, sir. Got it, sir.
Got it? So here it will be Px of minus 1 into Fy given X equal to minus 1 of 1. Sorry, minus 1. And in the denominator, it will be Fy of minus 1. Okay, tell me in the numerator part, this is the case, right? 1 by 2. And for this case, it will be 1 by 4. See, this is Y given X equal to minus 1 is what? It's 1 by 4, right? Are you getting this point or not? I mean,
Sir, right. One more step in the middle of like Px given Px is equal to 1 given that Y is equal to Y. Then we formulate that P of X is equal to 1 intersection.
This case. Right?
Yes,
basically, this is something, this is the intersection part is we can split in the, we can write in the form of multiplication rule, right?
Yes.
The same thing I have written here, okay? Marginal of X into conditional of Y given X equal to X. Divided by marginal density of Y. First of all, this formula is okay or not? Tell me. This is something, are you able to relate with this one? Yes, no, anything. If
No,
you are
no,
not
no,
speak, I
sir,
will
no,
assume you are getting the
no, sir,
point.
no,
Okay,
sir.
so it's rather it's a good you can tell me
Sir,
whether you are getting or not.
no, sir.
Okay, where okay, first of all, this base theorem is clear.
Yes, sir. This base flow theorem is clear, sir.
Okay, through this multiplication rule, what we have decided throughout the x, this was the marginal density of y, right? This is something we have done.
Yes, sir.
Correct?
Marginal velocity of
Instead of b1, just treat x equal to x, right? So instead of b1, I have x equal to x.
okay.
Correct?
Yes.
Instead of conditional probability, I have this probability.
Okay. Yes, sir.
Correct? Divide
Yes.
by what is P of A? Marginal density of
P
A.
of
So
yes.
we are talking about instead of A, I have marginal distribution of Y.
Y.
Correct?
Yes, sir.
Is this clear to all of you now? Basically, this is just we can find through the base theorem. Is this clear?
Yes, sir. It is clear, sir.
Right? So question is x equal to -1 given y equal to -1. Okay. So we can simply substitute the value. So for x equal to -1, it's 1/2 into f y given x equal to -1. So for this distribution, if you see, this is nothing but uniform -2 to 2. That means I can write 1/4, right? Means 1
Yes.
upon 2 minus 2. And what about denominator part, fy of -1? Fy of -1 means what?
Calculated above.
Sorry? This only left part.
Yes, sir.
Why not second?
No, sir. This whole Fy of y. Total
No,
addition.
I'm talking of fy of -1 only.
Okay, okay. Sir.
Yeah, then tell me which thing we have to do.
Complete, sir. Complete with addition.
Are you sure? Fy of -1 I'm talking about.
Yes, sir. Both the party put the value -1 left side. Fy that become Fy of -1.
Okay. Just think little bit. Whether see this part is this 1/4 we got y belongs to -2 to 2. This part we got exponential when y is greater than 0. So -1 will be where?
On first part. Sir.
One first first term, right?
Yes, yes, yes.
Got it? I will tell
Yes.
you this 1/2 into 1/4. This will be 1. Okay, you will be able to differentiate just a few minutes. Okay, tell me what about probability x equal to 1 given that y equal to -1? That means px of 1 into fy given x equal to 1 -1 divided by fy of -1, right?
Yes, sir.
What about numerator part? Can you tell me? So first of all, it will be 1/2 into. See, you have to identify what is the distribution of this one. Okay.
Only
So
go for x for one, sir.
y
Yes,
given x equal to 1 was exponential 5, right?
yes,
So I'm
yes.
talking about when y is -1. So what is the probability?
0.
0, because it's not defined, right?
Yes.
Okay, and denominator part will be same case. So it's a 0. Now, when you have to add all, let's say I'm asking probability that x equal to -1 given that y equal to 1. Okay. In this case, I can write probability of x equal to -1 into fy given x equal to -1 of 1 fy at 1. Right. So now if you see fy is 1 now, I can add all the things. Okay. Because
Yes,
-2
sir.
to 2 and y is greater than 0, right?
Yes,
Okay,
sir.
so numerator part will be 1/2 into 1/4 because for this it's a from uniform -2 to 2, right? And denominator part will be 1/2 into 1/4 plus 1/2 5 raised to minus 5. Is this clear?
Got it, sir. Thank you,
Got
sir.
it? Okay. Okay, tell me one more thing. You should tell me within a second. What is the
Sir,
distribution of probability x
sir,
equal to -1? Yes.
Denominator part is not clear, sir.
Why? So fy of 1, right? So fy of y is what? I have, you have 1 into 1 by 2 into 1 by 4 plus 1 by 2, 5 raised to minus 5, right?
Hmm.
See,
I get it.
basically we have to see what is the support of x. Support of x is minus 2 to 2 and greater than 0, right?
Yes,
So
sir.
I'm talking fy of 1. Okay, so it should be true for everything, right?
Yes, sir.
Correct? For this also,
Simply,
for this.
simply we put y one in
In
place of
that one.
y, sir. Yes, sir. I got it.
Okay. So what is the distribution of this one? Probability x equal to minus 1 given that y equal to 3.
Probability
Not
of
in the answer.
Sorry?
This is not in range of y, sir.
Not in the? Yeah, tell me what will be the probability? Tell me. This will be half. What about this probability?
Is 0.
0, because this is the uniform minus 2 to 2. Okay. Beyond this region, it will be 0. Okay. So it's a 0. Is this clear?
sir, uniform minus 2 to 2 to 2 4 y, na sir, or x, sir.
See, this whole conditional is minus 2 to 2. Okay.
Sir, yes,
But
sir. Y is equal to 3, then it is out of range, sir.
yes. No, it's not about only y is equal to 3. It's about when y is equal to, yes, I mean, whether this is true or not, basically. Okay. Now, okay, the same thing, if I will change the scenario, suppose probability x equal to 1, given that y is equal to 3, that then when? It means probability x equal to 1 and fy given x equal to 1 at 3 divided by fy of 3. Now you will tell me what is the px of 1? It's half. What is the distribution of this thing? Tell me. It's the exponential 5, right?
5.
Yes, sir.
So it's
Sir,
a
how
true,
do
right?
we know that it's
See,
exponential 5?
I can define the exponential because it's a greater than 0 always, right?
Yes.
So it will be
Uh,
5 e raised power minus
15, sir.
15. Divide by in the denominator part. Tell me what it will be.
Sir, half into 1
Marginal
by 4.
density.
Half into
1 by 4
1 by 4
plus
plus
5 into
5 into
e to the power
hmm,
minus 15.
1 half also. Okay, now
Yes,
just
1
think
half also.
whether this will include or not.
Not, sir. It is not included.
Why it will not include? And if it will include, then why?
Sir, in which it is include? For what you are asking, sir?
I mean, in the denominator part, this term will be there or not? Because here y is equal to
No,
3 is
sir.
there. It will not be there, right? See, if you see, tell me, this part is what? Fy given x equal to minus 1 at 3 plus fy given x equal to 1 at 3, right? This is something in the denominator is there,
Yes, sir.
correct? So this is follow uniform minus 2 to 2 and this is following exponential 5, right?
Yes,
So
sir.
this is the true because here range will be greater than 0. Y can take value 3. But in this case, y
3.
cannot
Yes,
take
sir.
value 3, right? So
Yes, sir.
This is
it
out
will
of
be
2.
0. Correct?
Yes.
So you will be having only this divided by this and this is same. It will get cancel out. This is 1.
Yes, sir.
Clear?
Clear,
Okay.
sir.
Yeah. Okay. So you have to just a little bit. I mean, whenever you will do some questions, right? You will get some more idea. Okay. Let me tell you one more question, just distribution part, and then we'll try to wind up.
For every question, we have to remember the range
Yeah,
of
range you have to keep in your mind. Otherwise, see, everything is based on the range. If you're talking about discrete and continuous, okay.
yes,
Suppose
sir.
I'm saying I have defined one random variable as x plus z, okay, where so these all problems are from lecture video itself. Whenever you will watch the lecture video, you will get the more idea. Okay. Let me just try to explain. Suppose this is the case, okay? And I'm saying Z equal to, I mean not equal to, it's following normal distribution with mean 0 and variance, that's a sigma square, okay? And these two are independent. So question is, what is the distribution of Y, okay? So if you see, X is the discrete, right? Correct? To calculate the distribution of Y, okay, marginal distribution of Y, so we know X should be the discrete, right? Correct? First of all, and Y given X equal to X, this information I mean this should be given to us, right? Only then I can find the distribution of Y by adding throughout the range of X P X of X into conditional of Y given X, or okay. So this is something we should given or not?
We have, sir. We have to this.
First of all, we should be given, right? It should be given in the question part. Yes or no? Are you getting my point? What I'm trying to explain here? Question is, suppose I'm saying Y is defined as X plus Z. Okay. X is discrete uniform with these values. Okay. With each probability value 1 by 4, 1 by 4, 1 by 4, 1 by 4. And I information about Z. 0 comma, if it is normal, 0 comma sigma square. I am asking distribution of Y. We know if X is the discrete, then to calculate the marginal density of Y, we need one conditional probability, right? This part.
Yes.
Correct? Only then I can find the distribution of Y, right?
Yes, sir.
Is there any session from it? I mean, do you any session from 8 p.m.? Okay.
Yes, sir. Python session, sir.
Oh, okay. Then let me just summarize a little bit fast. Okay. So I'm saying, so we have, you can see, X is uniform -3, -1, 1 and 3, and Y has been defined X plus Z, and Z is saying normal 0 comma sigma square. Okay. So can I say here Y given X equal to -3? If X equal to -3 is then what will be the distribution of Y given? So can I say here it will be -3 plus Z?
Yes, sir.
For this case?
Yes, sir.
If -3 plus Z, then it will follow normal with distribution with mean -3 comma sigma square, because there will not be any effect by adding a constant. Yes or no? Same
Sir,
Y given X
sir,
equal, yeah.
sir, normal distribution is for Z, na, sir?
Normal distribution is for Z. That's okay. This is the X, right? If I'm
Yes.
saying X is -3, then what will do? Y given X equal to -3, it will be -3 plus Z.
Yes, sir.
See, normal Z is following normal 0 comma sigma square. Then -3 plus Z will follow -3 comma sigma square or not?
Yes, sir.
Yes, sir. This is a fine.
This is a fine thing, right? Basically,
Yes.
okay. Let's treat. Okay, I'm talking expectation of -3 plus Z. Expectation of -3 plus expectation of Z.
Yes, sir.
Expectation of a constant is that constant plus expectation of Z is 0. So
0.
it's -3, right? The same thing I have written. Okay. And we know there will not be any effect by adding a constant on the variance part. Okay. So variance
Yes.
will remain constant here. So it will be -1 plus Z normal
-1 sigma.
-1 comma sigma square. Same. Y given X equal to 1, it will be 1 plus Z
Plus
normal 1 comma
sigma.
sigma square. Then Y given X equal to 3, it will be 3 plus Z normal 3 comma sigma square. Now you have all the conditional probability and all the discrete distribution. Now you can find the marginal density of Y. Yes or no? Correct?
Yes.
So this is something we have to take care about. So whenever you will be solving some more questions, you will get the idea. Okay.
Okay, sir.
Okay. So I think we have covered almost every topic. Okay. So
In week 5, sir.
yeah, in week 5. Okay.
Yes.
You can solve the questions. I think in the upcoming session, I think Friday there is one session. Okay. So Friday it's the TA session, right? If I'm
Yes, sir.
not.
Sir, I have one doubt, sir.
Yes.
Sir, in one function, y is equal to x square,
Hmm?
where the support of y was 1 to 9, we
Hmm?
have used bins. And in the subsequent example, we have not used bins. Why, sir?
Okay. Did you join the session late?
I missed that part, sir.
Okay. So it's good you could ask at the same time, right? No problem. I will explain you. I don't have any problem. The thing is, if you all ask at the time, then you will get the idea with what we are doing. Okay. You're talking about this one.
Uh, where y was, support of y was 1 to 9, sir. Y is equal to x square. Sorry, 0 to 9, I guess.
Yeah, this one, right? Okay. So can you
Sir.
tell me why 0 to 9, right? Correct?
Yeah, that I got it, sir. But why have we used bins here and not in the
Okay, okay.
subsequent example? 1/4 we have used it, right?
See. I will explain. First of all, can you tell me if I will write, okay, so if I will write probability x square less than y, then I have to write probability minus y lesser equal to x lesser equal to square root of y, right?
Yes, sir.
Correct. Now, can you tell me if I will take any value, let's say I am going to take any value, let's say till 2. If y is equal to 2, will this be always true? This case, this case will be always true.
No, sir.
We can't, right? Because upper limit of x is still one only, right?
Yes.
That's why we have taken splitted 0 to 1, then 1 to 9. Okay. So if you see, if you put any value from 0 to 1, okay, so it will always be here minus square root y to square root of y before 1, right? If you see, if you put any value, let's say I'm putting 0.5, then it will be minus 0.5 less than x less than 0.5, right? Square root of these two, correct? So it will be
Yes.
here minus square root of 0.5 square root of, if I will put 2, it will not be true, correct? So for that case, what I will taken, it will be minus square root of y to 1. Okay.
Okay.
If instead of upper limit 1, if this is the case, suppose upper limit is till 3, for example, okay, then there is no need to splitting up, because for any value of y, this case will always be true. Got
So
it?
we need not take bins.
Because see, thing is we have to just think, because upper limit is still 1 only, okay?
Yes, sir. Got
Fine.
it, sir.
Okay, let me tell you one more thing. If you see in this example, this is uniform minus 3 to 3, y is modulus of x, right? So modulus of x graph is like this, minus 3 to 3. If I will put, I will get modulus x less or equal to y minus y to y. If I will put any value of y will be here from 0 to 3, right? So if you'll put any value of y in this case, let's say 2, you will get this case, right?
Yes, sir.
And this is the true, correct?
Yes, sir.
This will always true till 3, always, right? 1,
Yes.
1, 1.5, anything, right? The same question, if I have changed, instead of 3, upper limit is true 2, okay? Then we have to make the bins. First bin is 0 to 2, because if we will take 0 to 2, that means if you will take any value of y, then it will be true, correct? This case will be true, right?
Yes, sir.
Correct. If you will go after 2, let's say 3, then you can't write this case, right? You have to limit upper bound till 2, correct?
Yes, sir.
So we have split it. Okay.
Okay, sir.
You have to think where the condition is not going to satisfy. Got it?
Yes, sir. Got it.
Yeah.
Thank you, sir.
Okay, then I think you can just solve the more questions. Maybe Friday TS session, instead of TS session, there will be solve with the sensor. I will update the calendar itself. Okay. 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 Then thanks. Hope you got the
Thank you,
idea.
sir.
Okay.
Thank you, sir.
Yeah. Try to solve the question. We'll meet in the. Okay. Thank you.
Thank you so much, sir.
Yeah. Thanks. Bye.
Bye, sir.